Alright guys, so you had seen what happens if you play this lottery game for 1 year continuously. So let us visualize what happens rather than seeing the net profit or a net loss. Let us visualize it. So let me say, by visualization I mean let us plot a graph, basically graph with x-axis and y-axis. X-axis be on which day, what do you win or what do you lose. On day 1, what is the amount you have in your account. On day 2, what is the amount you have in your account. Let us plot that and let us observe the trends. So to plot it, we'll have a package, that is Matplotlib. I hope you had used the same package. I guess it is in your crowd computing experiment, the jelly beans experiment. I hope you had used this package. Let's just revisit the same package. We'll import it. Import matplotlib.pyplot. The name is very big, and given that we need to use it a lot of times, it's difficult for us to type this bigger name. So let us use a shorter name, an alias name. To use that, you will have a keyword as. You have to say as and use your short name. So let me say PLT. So instead of telling matplotlib.pyplot, I'll be telling PLT. This is an instruction. This is what this means. So I have imported it, and now I need to plot it, right? So I need x-axis and y-axis. So I need two lists. X denotes the x-axis quantity and let y denote the y-axis quantity. So on the beginning of each day, I have to increase one value in my x-axis at day 1, day 2, day 3, something like that. So at the beginning of the loop, I will add that to my x list. X dot append is the functionality to add some element into your list. So what should I have? It is the first day, means I have to add 1, second day 2, third day 3, something like that. But your for loop, it starts counting from 0. But you want, given that this is a visualization for humans, we need the counting to start from 1. So how can we tackle it? Just add 1 to it and append it. So if I is 0, I want 1. I is 1, I want 2. So I basically want the value of I plus 1. So let me append it. I plus 1. Okay. So I have, the day has started. I bet something. The organizer draws something. If it is equal, I win some amount, else I don't win anything. But to play this game, given that I am paying 100 rupees, I am deducting 100 from each instance, and after the game, what should I do? I have to, whatever the amount I have in my game account, I have to append this to my y-axis. That is, I have to plot the corresponding thing in my y-axis. So let me append that to the y-axis list. So that is y dot append. I have to add it to that list. The account has some amount, right? So let me say I have to append this value. So I had done that. So at the end of 365 days, what will be there in this X list is the corresponding day count, day 1, day 2, day 3 up to day 365, and y-axis, the list will have whatever the amount your account contain on that particular day, that will be available, and I want to plot it, right? So this is the net profit or net loss you have, and after that I have to plot it. So what should I say? plt.plot. This is the function. To plot it, I can say x and y. I want to plot these two things, and I want to show the plot. So I'll say plt.show. So it will plot the values with taking the days in x-axis as we had said, and the amount in y-axis, and it will generate a plot and show us the plot. So this is what these two lines are doing. Let us observe visually what happens with each day. Let us save the program, and now let me maximize this side. Let me maximize the pane, maximize the current pane, and now let me run the file. See, so there are sometimes you have an increase in your account, sometimes you have a money, but there is a huge fall. If you could see, this is really a very huge fall. So as you keep playing, you encounter more a loss. If you could see this, if you analyze, the fall is very huge. So that is what makes it, that is why they say lottery doesn't work. Okay, this is just once. Let us try again. See, even here you could see there is a loss at the end. Loss. And every time you just observe the y-axis, that is the amount, positive values are very less. Negatives are very high. Especially observe this particular graph. just 0 to 1000 is the maximum you had gained, but loss some 6000 something. Some days you had even had such a heavy loss. So that is why the take home message from this is lottery doesn't work. The amount they say, you pay 100, if you win you get 900, 9 times of what you pay. This is a tempting statement, but if you analyze the intricacies, it's not that you will win, they are actually cheating you, they are tempting you to lose a lot. So it mostly is the case that you will lose. So that is the take home message from this programming screencast. We had simulated and we had seen, and for those interested, the next avenue would be, there is some probability involved here. You could look into the math of it. Why is that happening? Why is that you lose a lot of time? So if you would analyze the probability of winning and probability of losing, you can get some insights. For those interested, you can check out the math behind it. Why is it that most of the times we lose? I run once more. This time I won. I run once more. This time there is a loss again. Loss. See, there is a lot of loss. And win, I had run some probably 6 times. Just once I had won. That is, by one I say I have a net profit. Most of the times the net profit or loss what I gain out of the game is a loss. Why this happens? You can delve deep into the probability aspects, the mathematical aspects. That can be done as an extension to what you have learned in the programming screencast. This you had simulated and shown that it will be a loss. Why that happens? That is being explained by the mathematical part. You can look into it. Alright guys, thanks for watching this programming screencast. Have a nice day.